I thought I would just give a short introduction to a small hobby project that I have been working on, namely converting StableHLO to CoreML. So first of all, let's talk about why this is useful at all. So I have been making a few models in a framework called JAX that I wanted to get running on my phone. You can see an example on the right side of the screen here, just a silly app. But basically, when you have your model written in JAX, you want it to be running on your phone, in this case an iPhone, using the accelerated hardware. And to do that using the sort of conventional method, it turned out to be a bit painful with the JAX ecosystem. So I tried to make that simpler. So if we look into the existing tooling that exists today, Apple has this nice Python library called CoreML tools, where it basically takes as input a TensorFlow or a PyTorch model. It compiles that to what's known as the model intermediate language in CoreML, and then it can save it as CoreML to a file on disk, for example. And once you have the CoreML file on disk, you can just transfer it to your phone and run it with acceleration. So that's kind of the happy path, everything is just working. So the easiest way to go about this, using all of the existing tools, would just be to take your JAX model, you convert it to TensorFlow using a built-in conversion step, and then you use the TensorFlow to ML conversion tool provided by the Apple CoreML tools. So there are a few reasons why I didn't like this too much. First of all, I need to pull in that dependency on TensorFlow. And second of all, there are two compilation steps now that I have seen break in some cases. One going from JAX to TensorFlow and one going from TensorFlow to ML. And it has been very frustrating when one of the steps fail, because you need to go and dig around in the code to figure out where it goes wrong, and that can be quite time consuming. Also, I thought that, okay, JAX is represented by this thing called StableHLO, which itself is a sort of an intermediate representation. So by going from one intermediate representation to another one, I hope to basically save a bit of complexity, whereas currently in CoreML tools, they have to support the full API of TensorFlow and PyTorch. So hopefully this approach will turn out to be a bit simpler as well. So yeah, exactly what I did in this project is to sort of scrap the TensorFlow to ML conversion, just go straight from JAX to ML, basically. And that's what this project is about. So the edge here between StableHLO and ML is what is in this GitHub repository. Let's just have a look at what this ML language actually is. So it's basically a program that's defined by a list of operations. You can see the actual list here, but let's just give a very brief example to sort of get an overview. A CoreML file consists of a function called main, which is like the main entrance point. It has two arguments, or in this case 2 arguments. It could have any number of arguments. And you can see we have some type information about the shape of the tensor and the data types. Then comes the function block that describes what computation are we going to do. In this case, we're just doing a matrix multiplication, and then we end up returning the result. So if we dive in a bit deeper into this ML language, so obviously it's a different representation than StableHLO. So it's not one-to-one compatible between the operations in each language. So there's a bit of translation that's needed on that front. Also, if we look at the control flow supported in ML, then it does support while loops. It also does support conditional execution, but it does not support function calls, which is supported in StableHLO. That means that every time we see a function call, we need to basically unroll it in our conversion and inline the operations from this function call. So I have done this in this project, and I have implemented this list of operations, which sort of turned out to be the operations that I needed for my specific models. This list is by no means complete, and also some of the operations may have limitations compared to the full API service. For example, I know in the convolution operation I've implemented, I've made some assumption about the batching dimension. And also I haven't implemented all of the data types. So it's more like a proof of concept what I have so far. So let's move on maybe to how to actually use this. So first of all, you need the package itself. It's called StableHLO CoreML experimental. Just install it through pip. And then you need these two other packages to enable JAX to export your model to StableHLO. Once you have that, you can write your JAX code. So in this case, I just have a very simple JAX function that computes a batched matrix multiplication. And then you specify what input shapes you expect for this, this function. You can export it to StableHLO and create the module. And once you have done that, you get out the StableHLO code. So in this case, yeah, 2 arguments, has these shapes, this data type, it does this .general operation, and then returns the result. Then the next step using this new conversion is to call the convert function from my project on this HLO module to get the ML program. And that's done in this line. And then afterwards you have the ML program, but you need to transform it into a proper CoreML model, which you do by using the CoreML tools function for doing this. And then in the end you'll have this CML model, which you can either just save to a file, import into Xcode and use it as you wish, or in this case I just print out the ML program to get the actual code that we have generated. So if we have a look at it, it's very similar to the original StableHLO in this case. I think the main differences is that we do a cast to FP16, which is done by some optimization phase in CoreML tools because they like floating point 16. And more than that, instead of the .general operation that we had before in StableHLO, it has now been changed to a matrix multiplication, which is the corresponding operation in CoreML. Cool. So that's more or less for what has been implemented so far. Obviously, since this is a hobby project, I haven't done any formal evaluation or performance comparison between the existing PyTorch and TensorFlow frontends to this new StableHLO frontend. I also have a bunch of restrictions in the implementations, as I said, with the batching dimension on the convolution, the data types, only supporting a subset of all of the operations. I currently only support iOS 18 because of the way I have implemented the .general implementation. And then currently, it only works for running inference on your models. So all of the training and stuff needs to be done on the JAX side, and then once it has been trained, you can get the StableHLO module, which you can then compile and run on your phone. One very interesting thing I would kind of want to try at some point would be to convert PyTorch and TensorFlow models to StableHLO, and then use that StableHLO to generate the CoreML model. I think it has the potential of saving a lot of code and complexity in CoreML tools, and it serves as a very good sort of benchmarking tool to see if we introduce any inefficiencies in the compilation step, because we have a very clear benchmark to compete against, namely the existing implementation. But yeah, I think that's about it. If you guys have any questions or comments, or want to contribute, feel absolutely free to do so. You can either find you can find it on GitHub. Otherwise, I'm also available on the OpenXLA Discord chat, where I'm called Casper, so feel free to reach out.